All right. So last week, I think this is the slide where we had stopped. If you all remember, at least Salman, you were there last week, or I think Tuesday, not last week, but Tuesday.
Yes,
And
yes.
I had a homework given out to all of you, whether you were there or not. But Salman, were you able to come up with some answers on those use cases?
Yeah, I do have.
Okay, so the question was, I believe, come up with a use case five which are NLP and five which are computer vision.
Yes, yes.
Okay,
Yeah,
so please go ahead.
yes. So for NLP use cases, I have like speech recognition, like which we use. So it used to like identify speech and then classify the speech and then understand it. So that's one use case. And then chatbots, which we have in multiple websites to talk to like the users or customers. And then spam detection of emails or SMS also uses that. Like it can identify repeated keywords from its own class and then classify whether it is spam or non-spam. That's one
Okay,
more. And then like sentiment analysis in social media. If there's any new product and like we need to understand like if the brand is being going well or not, then sentiment analysis can be used to see if it's positive or negative reception from the customers. And Grammarly also uses the NLP to like correct the grammar, the text, and if there's any like errors, it will suggest the rectification. So that's what I thought for NLP. And then for computer vision, like we have face recognition in our phones, and then medical imaging in the hospitals, like for like example those X-rays and all those things. Self-driving cars also uses it, and vehicle classification in the in the traffic light to like monitor the vehicles and all that. And also in farms, like we have this animal monitoring, like computer vision, like to maintain the count of animals and see where they are. So these are what I thought for computer vision.
okay. No, these are very valid use cases. So Shruti, you heard it so far, and I know you are already doing your master's in data science, if I'm not wrong, or related field. Would you like to add any more example in either of this domain, whether it's NLP or computer vision?
So yeah, as Salman said, it's like basically you take one domain and either do classification or regression type of task in computer vision. Basically, like I'm also working on classification and also medical imaging. Yeah, I think that is the base scenario, and we can extend our projects on the base in which Salman has said.
Okay. So can you think of an industry which is not Salman mentioned in any of that domain? Doesn't matter NLP or CV. Can you give me one example outside of what Salman?
Oh yeah, of course. Like if you take my example, then I am like I told you last time, I'm working in solar data set. Like we are predicting if we will have a flare in next 24 hours or not. Yeah, mm, and in NLP, like it's as he said, we can use for speech recognition and also maybe in recommendations.
Okay. Recommendation of what?
So like if we talk about e-commerce websites like Amazon, we can process the reviews that the users provides and then filter out if it is a positive response or a negative response, and we can maybe like seeing the context similarity, we can then recommend our users like the similar products that they are searching for.
Okay, so if you are Amazon, would you recommend based on the user review, or you would recommend based on what others have purchased?
Yeah, like there is a recommendation system domain which actually is like content filtering, which
Uh-huh.
you said we recommend users seeing the buying patterns of them as well as the similar users like them. But then if we have to get go one step forward, then what I said can also be done. I know that is a long approach, but yeah, that can be done.
Okay, no, no, that's fair. I mean, to come up with a use case, yes, that's a valid use case from a uh, example point of view, no doubt. Very well. Okay, thank you. So coming back to the slide here, right? Particularly here, last week, to recap it, we discussed the life cycle of an ML project, and typically it starts with the scope, and always ML project is never, or any machine learning project or AI project is never a technology problem. It's always a business problem. And what kind of business problem you are solving, whether in your case, Shruti, you gave an example of the solar flare. At least somebody, maybe it's NASA or whichever the institute is sponsoring it, is looking to gain something out of it, right? Whether it's for the cause of human, whether it's to improve the profit, whether it's to improve the customer experience, doesn't matter. But at least in this scenario, they want to find out whether the solar flares are occurring, when occurring, and whether something is coming up in next 24 hours, so that they can prepare for it and then fight against it, right? And then prepare the human being for potential uh, more damage it could cause, based on what is the predicted. So in a nutshell, the ML problem is always a business problem, and it always starts with a business problem. But you as a project sponsor, and you can be a project sponsor. I'm not saying that you are not a project sponsor, but you or whoever is the project sponsor, they want to scope it out the project. Otherwise, that will become a very big project, and without having that scope, the next layer, which is or the next step about preparing the data would become challenging. Like similar to example of your recommendation engine, if your recommendation is to recommend based on other people purchase versus other people reviewed, both require a different kind of data set, right? To to recommend based on the purchase of other people, you need the data which are other customers have purchased items, versus to recommend based on the review of an item, you need a data which are the product reviews by other customers, right? So in categorically speaking, both are a different data set. And based on that data set, your entire model build and train phase would change. So as you have the data set ready, prepared, whether it's transformed and stored somewhere, you would use appropriate algorithm, and we'll go into some of the nitty-gritties of those algorithm in a second. But you would select an algorithm based on whether it's a supervised, unsupervised, reinforcement learning, or whichever kind of model training you want to build with. You pick an algorithm which is applicable to your use case. Maybe a recommendation engine is what you want to do, or anomaly detection is what you want to do. And you would pick that algorithm. You would apply your data with that algorithm, and you start building a model or training a model to meet some of those criteria. Before you start training your model, typically what you want to do is you want to split your data, and it's called a data split from a technical terms point of view. But you would typically split in general at least in two category. One is the train data, the other is the test data. And the reason you want to split is you want to, let's say you have a 10,000 customer, and then we go with an example of recommendation system, what Shruti was mentioning earlier, is if we want to recommend based on the review, that means we find the review of those products and we use that review data as our source. And based on that, we start predicting from a recommendation point of view. Uh, Before we start building that model, we split the data into train and test. And the reason we do it is we want to test our model to see how it's behaving. And when we say how it's behaving, when you train a model, it's possible that your model may perform the best if it has the same kind of data for the test. But if you feed a different data, suddenly your model will start behaving abnormally, or it might give you a wrong output. And we will look at some of those other metrics when we talk about the model building and training of what you should be watching out for. But there could be a false positive, there could be a false negative, and so forth, right? So you want to watch out for, and for that reason, we try to split the data in train and test, and then make sure that we are testing against random set of data and try to assess the accuracy of our model before we deploy that model. And deployment is where we want to assess how that model is behaving from a real use case point of view. What are other scenarios we need to present so that model works the way we want? And we want to continuously monitor that model, whether it's from a drift point of view, and drift can be many. One is like a data drift, if your data changes and then you want to assess how your model is behaving, or there could be a model drift or a logic drift, and that may abnormally impact your model output or model result. So you want to constantly monitor your model for some of those drift. At the same time, as a part of software ecosystem, because model deployment is nothing but at the end of the day software deployment, and you want to keep an eye from a software point of view whether your CPU and GPU and any other system metrics are behaving in the right way, whether you are running out of memory because you have so much data, or your model suddenly grew without your knowledge, and because you have a pipeline which is deploying your model and you don't know whether your model size has grown, which may not even fit into the memory. So there might be many factors to consider when you are running that model in production from not only your model lifecycle point of view, but also software development lifecycle point of view. Okay, so before we jump on to the next slide or topic, any questions, Shruti or Salman?
No questions.
No question.
Okay, all right. Let's see if this goes on to the next slide. Would it go? Okay, so here is a very high level lay of the land. And when I say lay of the land, it's a thinking of when you need to apply some of the software development skill versus when you need to apply the machine learning skills. And there are many situations where you need to apply both. And typically, if you think from that point of view, your model development, whether you would like to develop the model or whether you like to use the existing model and existing framework, it's up to you completely. So the way I have laid it out here is sort of a layered cake, if I use that term, right? And then let me see if I can add one more layer, because that is a mandatory layer regardless. And if we think from that mandatory layer, which is, I hope you can still see the new box what I added, right? Can you see that new box, EC2 network storage or compute network storage?
Yes.
Yes.
Okay, very good. So Again, I'm doing it on the fly here, but primarily at the end of the day, you do need a compute, you do need a network, and you do need storage. So when we say these three things, in the initial class we talked about EC2, right? So EC2 is it by default when you launch that VM, you have that compute, whether it's a one CPU and 1 GB memory or whatnot. You do get certain network throughput as a part of it. And you also get some storage, that local storage, or maybe you can attach some network storage and whatnot. That is a bare minimum requirement, regardless of whether you are using your AI skill, machine learning skill, software development skill, doesn't matter, right? So that is common. That is required for even software development or any software you want to deploy. On top of that layer, if we think from that virtual machine layer point of view or hardware point of view, Uh, there are certain frameworks created by larger companies, and you may have heard some of this, like TensorFlow, PyTorch, MXNet, JAX, and there are many more coming. Shruti, which one are you familiar with or you are working with?
I am familiar with PyTorch.
Okay, so do you know who developed PyTorch?
Facebook developed it, but I think Facebook developed it.
Yeah, you are correct. So Facebook actually developed the PyTorch. PyTorch again, it's whether we call TensorFlow, PyTorch, MXNet, JAX, it's all open source framework. And what it does, it sits on top of your existing compute, on top of your operating system, and it gives you certain API libraries, whatever we call it, SDK, to allow you to bring in your algorithms into that framework and do the model training, right? So TensorFlow is created by Google, PyTorch created by Facebook, as you said. MXNet, I believe, was created by Amazon, and JAX is a new entry into this list of frameworks recently, maybe a couple of years, 3 years, again by Google. Seeing the competition from PyTorch, I think Google came up with a JAX to compete against them. But if you are a data scientist, for example, right, and you want to build a model where you want to control many things on how your tensor would look like or how your model would behave, and you want to tweak a lot of parameters, you want to change a lot of configurations, you would rely on this layer. When I say this layer, you interact directly with the TensorFlow, interact directly with the PyTorch, and you build on top of it. Again, nobody is, at least to my knowledge, if somebody is writing their own PyTorch equivalent or TensorFlow equivalent, then they are wasting their time. But most companies would rely on things like TensorFlow or things like PyTorch or MXNet or JAX to build their model, right? So like Shruti, you are doing is you are building a model, you are using PyTorch as an example, right, to build your model, and then you are deploying somewhere and running it from a model inference point of view. But that is a very standard way. If you are a data scientist, you would start at that level. What Amazon, and here we are taking an example of a ML platform or machine learning platform. The name I'm using here as an example is Amazon SageMaker. So what SageMaker does is it provides you a set of tools and libraries on top of this framework, right? So if you are a data scientist, you need to do 20,000 things for your model to deploy. What SageMaker does, it made it easy for you, where there are many hooks, many libraries, many connectivities, and many orchestration layer they have built for their customer, so that it makes the life of data scientist easy and the productivity of overall data scientist uh, increases. So that question or the use case, what I believe Salman, you came up earlier was around that agriculture, right?
Yeah,
Where in the farm you have a lot of animals and you want to count those animals. Now, how would you count it? Can you help us understand what would you do to come up with the end result, right? I don't care about what happens behind the scene, but how would you count it from a business problem point of view?
I think heat sensors are one way to use.
Sorry,
I was thinking like heat sensor, like
sensor. Okay.
yeah, infrared, so you can sense the heat from the animals.
Oh, okay. So you are talking about heat sensor. Okay, sorry, I
Yes,
missed
yes,
the word
heat.
heat. Okay, heat sensor where you can
Sense the heat, and then
sense the heat. Where would you deploy that heat sensor?
I think it would have to be like in the barn where all the animals are there. I was thinking in that way. In
Oh,
the
okay, okay.
barn,
So in
like
the barn where you have animal in the
yes,
in the stable somewhere,
yeah, in
right?
the shed, and then
So in that shed itself, you want to have some sort of a sensor, which
yeah,
is
on the top maybe.
okay. Uh, Good idea. I like that idea. Okay. What about any alternate approach from your thinking?
I would have to do some more like research on that. Let's see.
Okay, so the use case you came up was about, and then the reason I was asking you because that use case from what you described earlier is was in the domain of computer vision, right?
Yeah,
And I want to say that every use case which is computer vision, and I can be wrong, but most of the use case what I have seen around computer vision is always with some form of a camera.
yes, that's true.
Okay, so if you are, let's change your thinking now. So you are that farm owner, right? You own that farm. You have that barn, and you have all the animals. And instead of heat sensor, I have given you X number of cameras. You decide how many cameras you need. What would you do now?
I guess I would like mm, I would attach them on the ceilings, like all around the barn, and then use that.
Okay, so
I
what
have
would you
like
do?
multiple angles.
Okay, so you have multiple angles. Then you will, what would you do next?
I mean, like there's this like tool like in computer vision which it uses to count animals and faces
Okay,
and all that.
okay, going in the right direction. Shruti, would you change anything here?
So we're talking about counting a number of animals, right?
Correct.
So an approach to this will be maybe like as you said, fitting the cameras and using some type of computer vision to like detection or segmentation like networks to like detect where the cows are and then count it. Like it's a deep neural network maybe.
Okay, you spoke out so many jargons. Sorry.
Oh,
Salman, how many
okay.
jargons you understood so far from what she was saying?
I mean, I understood quite a bit, and yeah, and I
Okay,
think she's saying correct what she said.
right. So in a way, yeah, I mean, both of you are correct. Nothing wrong with either of those approach, and then you can apply both approach. Where I want to uh, go with that approach is in the first approach, what Salman you talked about, where you have a camera and you detect a cow, for example, right? And then you add up and you build a system which kind of telling you that okay, there are 20 cows. I counted 20 cows from that camera, and it does the job for you, right? In a way. And the second way, Shruti, what you described was applying some sort of a deep neural net, right? So, and then that is also valid. I'm not denying that. And it's possible that if you have a unique animal, hypothetically speaking, which does not exist in the world, and your system or your pre-trained model cannot recognize them, then you want to build your own deep neural net with your own data set, and then you want to train that model to help it understand that this is the new hybrid cow what I created, and this is how it looks like, and you go and count them, right? So in where I'm going is in scenario one, Salman, you are using what we call AI services. Okay, and I'll show you an example of AI services, and it's perfectly all right where you can use AI services, what Amazon or Google is offering, where you as a engineer, let's put it this way, you as an engineer, you do not need to build a model, right? A model is pre-trained for you. So if we go in this life cycle, Amazon has defined a scope. Amazon has the data. They built a model and they already deployed that model for you. And all you need to do is you become a software engineer and you apply your software development skills and you hit the API endpoint of that AI service and it will send you the result back. Right? So you make a REST call to that service. That can be any service, and we'll look at those services. But in this scenario, let's say it is a speech to text was one of the NLP example you gave, right? Or that Alexa thing, what we talked about when we say, "Hey Alexa," that converts speech into a text somewhere. That most likely is relying on some of these AI services which convert speech into text, right? And you don't need to build a model to do that. You can send that request to Amazon service and Amazon will do it for you, right? But if you have a unique use case where you want to count something which is not in their services or not offered by the services, or you have your own personal data because the trained model is using the data whatever Amazon is using, right? Here the data is not yours data, but it is Amazon's data. But you have your own data set and you want to train using your own data set, then you come down to either this level where that platform is available for you, where you can uh, augment a lot of the activity to the platform tools like SageMaker. Or if you are an advanced user like Shruti, for example, you can hit the PyTorch directly, and using the PyTorch framework, you can build a model, train a model, and then you go about deploying that model somewhere. So as we go from, let's say, top to the bottom, your ML skills or machine learning skill, and even in some cases, statistic skill would be required. As you go from bottom layer to the top layer, you don't need a lot of ML skill, and your software development skills should be good enough. Am I making sense so far?
Yes.
Yes.
Okay. All right. So let me jump to a different tab here and then we'll come back here. But what I wanted to show is exactly what Salman was asking us to do. Okay. So there is a service called Amazon Recognition. Okay. So I'm on AWS console, by the way, right? I think, Shruti, you've been in the session where we gone through the AWS and some of the basics, right?
Yes, I was there.
Okay. Right. So I'm on AWS console here, and then all I did is I search for recognition. Right. Again, it's typed differently. It's not RECO, but it's REKO. I don't know why, but again, that's the naming convention of Amazon. I don't want to debate them. And what this is, it's a deep learning based visual analysis service. And Shruti, are you familiar with this Amazon recognition by any chance? Just curious.
No, I have not used it yet.
Okay, all right. So we will try a demo again. I'm on a console. I'm gonna try a demo here. And what it happened in this last 3 seconds, they have a sample images, couple of sample images, and that sample image was applied to that recognition service, right? So here, if I go back to this is an AI service, okay? And in that AI service, we supplied an image. This is the image, right? A picture. And that picture is what? We have a building, we have a car, we have a road. Somebody is trying to do a skateboard stunt and whatnot, right? So what it did, the moment on that sample image on the right side, it's giving us a result and with some accuracy on the right side. It says it's a neighborhood. So yeah, it seems like a neighborhood with a 99.9% accuracy. I don't know why it's not 100%. That's beyond me. Okay, that's fine. It's a city, can be a city, can be a town. It's a street. Okay, it's an urban. Okay, why urban? Maybe because it's a building next to it, couple floor, 3 floor, something like that. Okay. Road, yes, there is a road. There is a person, so it detected a person. Here we go. And then we can see that label, right? And then there is a bounding box. This is the square around it. It's called a bounding box, right? It also recognized what is something called a skateboard, right? And there are more. Again, it's not done. Car, vehicle, transportation, and as we see scrolling down, right? The accuracy is sort of going down. So there is a shoe. It did identify that this guy is wearing a shoe. And here we go. But it's not confident. I mean, it is confident that shoe has a confidence of about 95% almost. And it's a very tiny shoe from a picture point of view, right? But at least it identified that there is a shoe or there is a footwear, there is a clothing, there is a wheel. Yeah, there are so many wheels, right? And then machine and building and architecture. But let's see what it identified, which is a low confidence. And sedan. So it says, okay, 55%, I'm sure it's a sedan. 55%, I'm sure it's a license plate. So there are license plate. Again, it's, I don't know where it is. Is this a license plate? Oh, that's a wheel. There should be a license plate somewhere. Again, I don't know where that license plate identified is, but you get the picture, right? Or you get the idea of what it's doing. Is it clear enough for from this picture?
Yes, and this is like
Yes.
the idea which I also had for the animals. It will use
Yep,
some
yep.
kind of AI and tool.
Correct, correct, correct. So this is exactly where you can apply the same logic to your animal pictures, right? Where you have a
Yes,
camera that is that is taking a picture at every, let's say, half an hour, 1 hour, whatever is your frequency, and then it does its magic, right? So what here in this service, recognition service, Amazon has done is they have gone out and then maybe uh, found millions of images. Okay, when we say data, in this case, it has to be images, right? And those images has to be labeled. When we say labeled, because I give this image, but if you tell this is a skateboard, I tell this is a skateboard, but somebody else may say, no, 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 this is not a skateboard. This is a wheel or something like that, right? Okay, I'm just hypothetically guessing it. But that means each object has to be labeled, right? And I don't know why it did not detect a tree, but it should have detected a tree as well. But technically speaking, all data has to be labeled. So what Amazon has done is they somehow procured or found out many images. Each image, they labeled it or get it labeled somehow. And then they trained that neural network, what Shruti was talking about. And then they expose that neural net or that model to their customers in form of an API endpoint. right? And all we are doing is we are uploading an image, and it's recognizing that, okay, this is what the image is, and it's giving us the result. Make sense?
Yeah.
Okay, let's look at the second image. So here is another image. It looks like this is a New York. I can be wrong, but okay, so there is some waterfront and a city, right? So the moment I uploaded and took half a second or whatnot, but these are the result. It says it's a city, so it's able to identify what this overall layout is, right? Cityscape, urban area. It's not a rural area. There is a building and there is a tower as well. There are architectures. It's a metropolis and many other attributes, like there is a waterfront, there is a water, it's a high-rise building, there is a boat. I cannot see that boat. Okay, good, good. Amazon found out there is a boat. Okay, there is a vehicle. Maybe they are considering boat as a vehicle and boat as a transportation mechanism as well. There is a tower, so it identified this as a tower. I don't know why other are not identified as a tower. There is a sky, so it knew that there is a sky, and it's an outdoor, it's not an indoor. It's a nature, it's a downtown, there is a scenery, and so forth, right? Make sense?
Yes.
Yes.
Should we try something else here? Should we try with some random picture?
Yeah, sure. And I also had one question, like, is it
Please.
possible to like to use this on a video or something like this
Uh,
software,
yeah. You can
Amazon
use it
recognition?
as a video as well. Rekognition has something called Rekognition video. Here, video demo. Let's see that, right? There we go. So it's a sample video.mp4. Again, I don't know whether the audio will get populated or not. But Jeff Bezos, he's no longer a CEO, but he was Amazon CEO. And then this guy is Werner Vogel. He was a CTO of Amazon. He's still a CTO of Amazon. And these two guys are talking, right? So it's a 20-second video. And we played that video, at least just for our own sake, right? And it detected that there are two people, both are celebrity. I mean, Werner Vogel is a celebrity, on his own way, but Jeff Bezos is definitely a celebrity, right? And then it's giving us the labels like they are human, there are people, they are person, there is an audience, there is a crowd. Again, I don't know. The 20-second video doesn't show the crowd or audience, right? It was purely these two guys are talking. But there is a furniture, so I think there is a chair they recognize. Yeah, chair and the table. There is a beard. Okay, yeah, Werner has a beard. There is a chair and then many other things, right? And it you can download this as a response as a JSON file. So those who are familiar with the software development methodology, once you have a JSON file, you can literally do anything with that, right? And it's not just stored video. You can stream a video. Like this is a Ring doorbell video, if I'm not wrong. So yeah, my home has a Ring doorbell and it has a similar view. That's why I know. So here on the right side, we see person package, at least a notification, and Ring gives you that notification that there is a person outside or a package outside or something in that sense when it detects in a periphery. And this is a summary. I mean, it's in JSON, but that stream was sent to this system, this recognition system, and it detected this output, right? So name as a package. Okay, should we try one more? This looks like a city view. Okay, so there is a person at 900 millisecond. There is a pet detected at 1800 milliseconds. So it's giving us exactly at what duration or at within that frame of a video, at what point the person was identified and what point the pet was identified. And again, in this scenario, or maybe this model is only trained to identify pet and person and not, or maybe handful of things. And then that's the reason probably it's not detecting any other things like the tree or a pole or whatnot, right? Making sense?
Yes.
Yes.
So there are many demos here, right? I mean, we can go through each of them, but uh, yeah, Jeff Bezos again. I think this one was very popular during the thing called COVID. I'm sure you all remember COVID, right?
Yeah.
So PPE detection, right? There was a constant need in the workplaces where they want to have people wear mask, right? And if you don't wear a mask, that means either you are at risk or you are putting somebody else at risk, right? So what companies used to do is they used to stream or take a picture at random interval and send it to the service, recognition service. And recognition service will take that picture and identify whether this person is wearing a PPE or not, right? So here is where probably it's detecting that whether face is covered is detected and face cover on nose, true, right? If that person did not had an face cover, probably it would have said, no, 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 we cannot see it. And here some of the other hand cover and head cover. This is in the industry, typically like a hard hat area where you want to have a head cover, right? And it's going to find out whether that's meeting a criteria or not. And maybe it's in the other area. Yeah, there we go. Hand covered. And where is the head covered? Head covered. Yep, head covered on the head is true, right? So there are so many things you can do without even training the model, right? This model is already pre-trained and it's available for you to consume for as a user. All you do is make an API call, provide the image or the video, and it will give you this kind of output, and you make a decision based on that output whether somebody is doing the right thing or the wrong thing, or whatever is your business decision is, right? Making sense or no?
Yes. Makes sense.
Okay, we want to try something, a public image or something.
Yeah, sure.
So Unsplash is a page where there are images, public images, right? So maybe what is the area you want to find out? Salman, since you are unmuted, maybe it's over to you. What do you want to try? Cow? Like since you were talking
Yeah,
about
maybe a barn.
barn, okay, let's say barn. Okay, so there is a barn picture. Let's hope it find out, or maybe which picture you suggest we should upload. I'll let you decide. Okay,
Yeah,
you have
maybe
to
the
tell now.
cow and
The one with the cow
yeah, I was thinking like maybe with animals inside the barn where we
looks
have
like
sheep and
it's not a public image, so we'll have to pay
okay.
for it. Let's look at barn with cow, right? And cow and something which is not unsplashed. Okay, so this horse, right? I think hopefully this or this one. Let's
Yeah.
see, right?
Yes. It has like a hen also in the background.
Download. Okay, Sarah Brown, something, something. So recognition, I'll go here, try demo, and load, download, Sarah Brown. Cool. So there is a calf. What is calf?
It means like a child cow, like a baby cow.
Oh, okay. Interesting. So cow, livestock, that is true. Cattle, that is true. Mammal is true. Animal, 100% true. Sheep, okay. But see, the score is
Yeah.
less, right?
63. Yeah.
Outdoor, maybe it's outdoor. I don't know. Straw, okay. So there are straw in a way. I mean, it's
The
not
the
the
hay.
drinking straw. It's a nature. It's a countryside. Not bad, right?
Yeah, it's pretty good.
Okay. I wanted to upload, let me see if I can find that image. And I don't know where that is. Should be in my downloads somewhere. No, I cannot locate it. But I was thinking of uploading one image, which is kind of a unique in its own. But somehow I lost the track where that image is. All right, we'll do different example. Anything else we want to try out? So here is one more thing: text in an image, right? So this is something very unique. So you have a picture, and you want to find out what are the text within that picture, right? So this picture has it's Monday but keeps smiling. It's Monday but keeps smiling. This is the result it gives, right? If we change that picture to this license plate, there we go, J389 NLT. So do you know how the DMV camera works now, right? In the traffic light.
Yeah.
So this is the request in a JSON. It's saying image. It's an S3 object. So this file is in S3 somewhere, right? Remember S3?
Yeah.
S3 is where we upload the
The
object.
temporary like storage.
Yep. So all we are doing is we are just passing this JSON object via API. Okay, it's an image. It's an S3 object where which bucket it is in and what's the name of that file. And this is the response you receive as a JSON. So it will detect the text. It says detected text, come line. Where is come line? Okay, I have no idea where it is. But at the end of the day, what maybe the confidence score is low. Yeah, it's 31% confidence. And that's the reason probably it's not displaying over here. But do you see come line anywhere in the picture? I have no idea where it is. Anyway, what it does is it also give us the bounding box. Remember that square, what I was talking about, this square. So this is the bounding box and it gives you the geometry. So this is the picture in a way, right? Whatever, 640 by 480. And at what location from a width, from a height, from a left and a top, where that picture is, or where that, that text begins, right? And this is
Yeah.
your,
I mean, I think those words are there on the top left. And
you see
then,
it?
yeah, yeah, over there, like,
Oh, that's a
it's a
coffee,
bit
I
blurry.
think. Yeah, it's a coffee, I believe. This is a coffee shop. I mean,
Yes,
I want
it's
to
coffee.
think it's a coffee shop, but maybe it read as a coffee, but somehow it detected the text as a come instead of coffee. Yeah. Okay. So that's that. And then the second text it detected is the license plate, right? So it's whatever the JN, JL39 NLT, and then it is confident, 99%. And this is the bounding box and the polygon where it is from an image point of view. And there is one more come. So there should be another coffee somewhere. I don't know. Yeah, there is another coffee here. So do we want to try this for some other picture where we have a text?
Yeah, that laptop one
Laptop
looks
one?
good.
Oh, actually, it's not. It's an ad. This thing, passion led us here.
Yeah.
Okay, Jan Schneider, registration, upload, Jan Schneider. Did it work or no? It did not, right? Image can't be larger than 5 MB. Okay, we get it. We'll find something else. Or we will download something which is smaller size. Can't. Let me make sure that size is okay. That's JPEG and 659 KB. Makes sense. All right. What do we see? Difficult roads leads to beautiful destinations. And so that's the beauty of it. So somehow it created this as a 3 word, right? B, A, and beautiful. It should be 1 word, beautiful. Are you guys still with me?
Yeah.
Okay.
Yes.
Okay. Just want to make sure it was quiet. But all right. So that's the APIs or AI services in a nutshell. I mean, we are talking about one. There are many. I mean, I can go on and on. Let me try translate. Okay. Salman, what is your native translation service? Sorry,
Uh,
native
I'm not sure.
language,
Uh, uh, it's Hindi actually.
Hindi. Okay. So let's do the other way. Translate into Hindi, right? Cool. Can you read it, right? Hindi, Hindi, you read it or you cannot read Hindi?
Yeah, I can read it. It says Namaste.
Right, exactly. Shruti, can you read Hindi or you?
Yes, I can.
Okay. All right. With question mark. Okay. So that is important. Punctuation is important. आप कैसे है? So again, this is all in real time what we are doing right now, right? So similarly, if you want to build an application which is doing a translation based on the word what you are sending, it will do the real time translation for you. All you are doing is just to send an API call, and it's using behind the scene exactly what we are talking about. This is entire machine learning lifecycle going on. They have a pre-trained model, and that model is doing that for you. And Amazon is doing the deployment, Amazon is doing the monitoring and maintenance and everything. And then they are giving us this fantastic result. So if you are Duolingo, Have you heard of Duolingo, for example?
Yeah.
What is it?
Yeah. Like it's the same as this thing, like we can translate on the spot, like
Exactly.
any words
Right,
and everything.
right, right. So you are doing it in an app, right? And it's kind of teaching you how to speak, how to learn new language at the end of the day, right? What do you
Yeah.
think they are doing? They might be using something like this, right?
Yeah. Maybe there.
Maybe they are. Okay. We don't know, right? Maybe they are, maybe they are not. It depends on what kind of data they are coming up with, right? Because in this scenario, Amazon has trained with their own data set, which is unknown. Maybe in some scenario, they might be telling publicly that what data they are training with, but in a nutshell, it could be unknown, not known to the user. So maybe if you want to train with your own data set and you need something other than this, whatever, 40 language, they are giving you the translation. You need the 41st language, which is not in the list, for example, right? Then you have your own model, right? Otherwise, you can use this service and then you can build your own Duolingo, right? If you know how to build an app and you know how to interact with AWS services as an API calls and then send and receive API data back and forth, you can build your own Duolingo. Make sense?
Yeah, it makes sense.
Okay, so question is, what do you understand from this slide? Can you summarize this entire thing? One of you, I need you to summarize. Who is summarizing it?
So this is like there are some computations, network and storage, which are in the base. Then there are frameworks like TensorFlow, PyTorch, and like which is used to do all the training and testing tasks. And some of the services, like in this case, it is Amazon. They will do the training and store the maybe weights in their end, so that they are making their AI services available to us, so we can call those AI services and do the inference in those models for using for our purpose. Like we can call it from API kind of stuff. We are basically doing the software dev skills, whereas if we move down, it will be more like technical ML related coding skills.
Yep, spot on. So correct, as you move up the stack, right, you are less using machine learning and more using software development. And as you move down the stack, you are more using machine learning and less using software development skills. And you still need to develop the software, but it's more of a machine learning skill is what you need compared to the software development skills, right? And what we looked at the examples, the couple of examples, whether it was a recognition or the recent example of a translate, both are using something called AI services, right? Where you can simply use your API skills at play and work with it. Cool. So let's do one more while we are on a console. Again, I won't go into AI services. Now I will go straight into the platform or the middle layer is called SageMaker, because Yes, in a way, you can be working in an AI ops or you can be working in an ML ops, right? But primarily speaking, we want to talk about ML ops, and an AI ops is kind of included as a part of ML ops. So let's talk about the ML portion first, and then we'll go into the actual ML ops details and then whatnot, right? So this is the tool or the platform as they call it, Amazon SageMaker, where you can build your model, you can train your model, and you deploy that model at scale, right? So in this scenario, you as a user are coming up with your data. So this is a typical workflow. You label your data. Again, you can do it in this tool. You can even ask other people to label your data. So when we were looking at this picture, right? If let's say this picture, hypothetically speaking, Salman, I'm gonna pick on you. What all you see here?
I mean, I see like some fruits, some flowers, and then scissors,
Okay,
and
see, okay,
like we have some citrus, some sort of like lemon or something, and
okay,
then a small bowl and seeds in that. And we
correct.
also have like some like pictures like behind there.
Mm-hmm. Okay,
Yeah,
so
and that's
okay, okay, you missed one thing.
leaves. I'm not sure.
Yes, then you missed one more thing. Okay,
Mm,
I'm picking on you. Okay, regardless. But so this flower petals, right? So which is where I was going, or at least I was teasing you. But another thing, what you would have said is, I see a strawberry, I see a blackberry, or whatever that name is, right?
mm,
Uh, I don't know what this is.
yeah, some seeds are there in the bowl.
Yeah, some seeds are there in the bowl, with no idea. Also, the Caesar is not a regular Caesar. It has a handle which is made up of some plasticky thing, right?
Some beads, I think.
Some beads, maybe. Okay. All right. What about
Yeah, the
the
pictures.
card? What you see behind it, right? It has a picture of the same bowl, if we look at it, right? In a way,
Mm,
something like that. So the point is, if you are developing an application, right, where you want to identify each and every detail within a picture, or you are looking for a particular item in a picture, right, which is there in the picture. Maybe you are looking for a Caesar, and since this is a unique Caesar, right, it's not a typical Fiskars or any other standard branded company Caesar, right? So the model which are created or pre-trained may not even recognize this as a Caesar. Valid?
yes.
So that means you need to label this and you need to tell the model that this is a Caesar, right? And you need to fetch that model few dozen pictures to identify that this is a Caesar. Okay, give me 1 second. I'm gonna find a picture which will make you laugh, or at least I was laughing when I saw that picture. Let me see if I can find that, and then I'll show you an example of what I mean, where it can be. Sorry, I have so many projects and pictures stored, which doesn't make my life easier when I'm trying to do something else. I guess we will have to wait till I find that picture next week. Next week. But anyway, my point is something which is unique, at least from this image point of view. And that image is sort of new, where model doesn't know what this image is, right? If we download this, let's download free. And if we put this into recognition, come on, where is recognition? The Brook Lark, try demo. And I'm saying, okay, detect the label. Upload Brook Lark. Okay, no Caesar. We don't see, at least in the 90% range, right? Not even 55%. I was correct. So no Caesar. Who detected this? This is a Caesar. Who said this?
Supposed to be, but it's not there.
Exactly. So the model may not know that this is that object what we use every day, right? Who knows it? Human, right?
Yes.
So that means there are many objects in the universe which are not known to models. It's known to human. That means we need to tell the computer that, hey, that's a Caesar. So that is called a data labeling. Okay. And there are various ways you can label the data, and there are tools available. And that's what they are telling, that there is a tool which the very first thing you need to do as a part of your machine learning workflow is label the data, because you need to have that labeled data. Then only you can tell, or then only the model will know what is what. If you teach this model that, hey, this is a lemon, this is not a citrus, then model will think, oh, it's not a citrus, it's a lemon. Okay. If you tell model this is a raspberry, not a blackberry, I'm just saying it for the sake of saying it, I think it's a blackberry. But if we tell model that it's a raspberry, it will show it as a raspberry, right? So it's all about what we teach the model, and for that we provide the label data. So as a part of this workflow in Amazon SageMaker, what they allow you to do is set up and manage a labeling job. So what does it mean? Is you can upload all your data, and an upload can be your images, for example, right? You have one image, but you may have 10,000 image, and you may not have time to do the labeling. So what you do is you set out a workflow and you hire a human to do the labeling. So what Amazon does is Amazon has a service called Mechanical Turk. Are you guys aware of that? Mechanical Turk?
No,
Have ever heard of it?
no.
Okay.
No.
Okay. So it's outside of AWS, right? It's not Amazon. It's not in AWS Web Services or things like those. But it's a Mechanical Turk is a human for hire in a way, right? Think of Fiverr, yeah, right? Are you aware of Fiverr or a freelancer,
Yes.
right? So what do you do on Fiverr or freelancer? You find somebody to do some job, right?
Yes, and then they will do it and they get paid.
Exactly. So Mechanical Turk is exactly, I mean, it used to be a company called MTurk, which Amazon acquired, but it's a crowdsourcing for business to hire remotely located crowd worker to perform discrete on-demand task, which computer cannot do. So, and again, it can be you ask that you request a task, and people will say, okay, I'll charge you 1 penny. Somebody will say, I'll charge you half a penny or whatnot, right? And that worker, those who wants to earn the money, they go and do that work, and report back into the same system saying that, hey, my work is complete, go and pick it up, right? So it could be as simple as uploading this kind of images 10,000 times and telling them with a bounding box, hey, this is a Caesar, and make sure you create a bounding box around this image and mark it as a Caesar, right? And the army of people will go and do it, and maybe they will charge a penny per image. So if you have a 10,000 image, maybe within $100, your entire work is done, and you have all these image. I'm just using as an example $100. It could be even less, depends on what the work is. But your data get labeled in no time. Literally, people will label it in 15 minutes and then give it back to you saying that, hey, your data is labeled and it's ready and good, ready to go, right? So that's where the labeling comes picture, and then you can set up those labeling jobs integrated with this machine. The Mechanical Turk. Again, it's part of Amazon. Amazon Mechanical Turk, right? The website is mturk, but it's still part of Amazon. Then once you have that label data, then you start building that model using something called notebooks. Are you aware of notebooks, Shruti? Are you working with a notebook by any chance?
Yes, I am.
Is it a Jupyter notebook or a Livy or?
So I have used like Jupyter Notebook, Colab, this SageMaker Notebook.
Okay, very good. So we will look at a couple of examples of Jupyter Notebook, but practically speaking, that notebook is most of the time, and I'm saying most because it can be any other kernel as well, but most of the time it's a Python-based notebook, and then we don't have a notebook here, but we'll create one in the coming week, sometime next week, to show you, and with a sample example, we will build and start working through a notebook, and we'll apply an algorithm, and that algorithm could be anything, and that is what I wanted to talk to you about algorithms. But let me finish the steps here. So we apply an algorithm. For example, Tuesday we were talking about anomaly detection, right? Salman, we were talking about COVID and how the credit card companies were treating online transaction as a fraud, right?
Yes.
So there is an algorithm in place for those credit card companies, and they realized and they flagged it, right? So what Amazon does is they have a built-in algorithm which works with this tool, SageMaker. There are 15 or 16 such algorithm for different use case. That fraud detection, what we talked, is one use case, but we'll look at all this in a minute. This tab. But using that and using the frameworks like the PyTorch or TensorFlow, you can start building and training your model. Once your model is trained, it's not typically ready to use, right? Most of the time you need to tune your model, because the moment you train your model, it may not be 100% or even 80% accurate most of the time. So you need to make it more accurate. You need to tune that model. And for tuning, you need to make multiple changes. Could be your hyperparameter changes, could be your data changes, could be some of the algorithm, how you're applying that may change. So that is part of the tuning. And once your tuning is done, then you deploy that model, right? So deployment is nothing but what we saw earlier, like recognition, right? Recognition, for that recognition service, Amazon must have gone through all this process, and then they eventually deploy that as a service. And now you as a consumer are able to use that service. So that means in a company, when you go and work for, and when your data scientist is building and training and tuning your model, it's your time as an ML ops engineer. You are going to deploy that model, and that model deployment has its own quirks. So here you can deploy that model using SageMaker, and there are 20 different ways you can deploy the model and 20 different ways you can inference that model. And finally, if you are ready and if you want to sell that model, right? If you build a new recognition, for example, right? Salman got excited and he said, okay, now I'm going to build a new recognition. He went through all the steps and he deployed it. But you want to sell that, right? Because who would know that Salman built this recognition? He can talk about it in Facebook and LinkedIn and Twitter, but for that he has to place a lot of energy. There is a thing called AWS Marketplace. It's like a Facebook Marketplace. I'm sure you are familiar with it. But in this scenario, that marketplace is mainly for AWS services, or rather, sorry, the third-party product which works in AWS, right? So that model what Salman built, a new recognition for recognizing the cow, for example, or counting the cows, right? Salman can upload that model in AWS Marketplace, and maybe a farmer which is sitting in Nebraska realize that, hey, I do want to count those cows. How do I count it? And he saw an ad from Salman in Facebook, and based on that, he landed up on AWS Marketplace, and he's using AWS Marketplace and to deploy it and run it and what, right? I'm just giving an example. It's not possible that farmer will come and use it in AWS Marketplace. Somebody else will come and use it. But the point is you can buy, sell, and do many other things with that mechanism. Making sense so far from a workflow point of view?
Yes.
Yes.
And it's similar what we see here, right, in this diagram in a way. I mean, this is written differently compared to what here they are showing up as a steps. Cool?
Yeah.
Okay, so let's go to algorithms. So here, and algorithms are the heart of a model, okay? Yes, there are many things required, like you need to have a right data, or you need to have a right label data. But even if you have a right label data, if you don't pick the right algorithm, your model is not going to work. So what Amazon does is they give you a certain built-in algorithm for different problem statements. So if you want to do an image classification, which is what we were doing in that recognition, or sorry, actually we were doing object detection, but image classification could be, is it a cat or a dog? That would be your image classification, and so forth. So the problem type, and there are pre-built and pre-built solution exists. There are pre-trained model exist. Some popular model you may have heard of, like a YOLO or a FastR CNN, or these are typically used in the image portion. There are many other use cases like tabular classification or regression. From a text classification point of view, you would use BERT. For a tabular data, you would use either a light GPM or CatBoost, and again for object detection, you go back to YOLO, and so forth. So there are, for each and every problem type, there are different type of built-in algorithms what AWS is providing. And if we go further down, here are again we looked at the supervised learning Tuesday, but let's say if you want to predict that if an item belong to a category, and that category could be like your spam filter, what you said earlier, right? Salman, whether that email is a spam or not. So in that scenario, it's called supervised learning. And what you are applying is either a binary or a multi-class classification. And these are some of the algorithms you can use to do that. Now, I'm going to go out on a limb and say that you can use XGBoost for pretty much everything, except few exceptions. But for most of the data sets, you can use XGBoost and you will get some result, right? So XGBoost is like a Swiss Army knife. I think I said it on Tuesday as well, but most of the problems from a classification point of view or regression point of view, you should be able to use XGBoost and you will get a result. Right? So similarly, if you want to predict a numeric or a continuous value, like estimate the value of the house, right? We took an example of Zillow on Tuesday, where Zillow is typically estimating the house value, your Zillow estimate or Zestimate, as they call it. It's a regression function, and there are many things you can use, but if you will find it, there is an XGBoost as well. So again, the point is for classification regression use case, XGBoost is very popular in a way, but you can also apply any other algorithms. And again, I'll share this list. Again, I don't want to go through the list in a class. I would rather have you read through and understand what it is based on what exists in the market, and then it will give you some more insight of what are the use cases you can solve using machine learning. And then those algorithms are regardless are going to be part of your MLOps curriculum, right? Making sense?
Yes.
Yeah, sounds good.
Okay. So I know we are almost toward the end of the 90-minute, and I want to give you all a few minutes to think and give me some critical questions. So what I can answer now for next couple minutes.
I don't have any question.
Okay, Shruti?
So, like, what will we cover in like coming weeks?
Okay, very good question. So the goal is to make you, or at least start with, and this is my way of teaching, is or at least I want to start with what we covered the algorithm briefly, but I want to start with the deployment, right? And I want to show you how the deployment works. So once you see, and again, we'll go through that example of how that object detection work or how that bounding box get applied, that will give you an end state of what it looks like. Because remember here, when we were looking at recognition, that was an end state we were looking at, right? This is how the actual system would look like. So I want to start with an end state, and then I want to go to that diagram, or rather here, that what it takes to run ML in production. So that ML code, what you developed or what exists from the data scientist, you as an ML engineer would need to help with the configuration. You need to help with the data collection, data verification, the resource management, the tools, the serving infra, the monitoring, and those aspects around how to run this model. Whatever that model is, that model could be pre-trained model, that model could be something you develop using that Jupyter notebook, or you go to this Hugging Face Hub. Are you aware of Hugging Face Hub?
I have heard of it, but I don't know what it is.
Okay. So Hugging Face is, think of a Hugging Face as a GitHub of models. So GitHub is nothing but a repository of all the code, right? If you need an example of a code, you will find it on GitHub most of the time, correct?
Yes.
I mean, I'll be honest. Okay, we are on recorded lines. I cannot say that. Okay, but yes, you will find an information about the code on a GitHub, and you can take an inspiration from there. Similarly, if you think from that angle, GitHub sorry, the Hugging Face is kind of want to be a GitHub for machine learning models, and it has what 89,000 models already exist, and each has its own licensing. I'm not denying that, but this GPT-2, we talked about GPT-2, it's literally generating your text, and you can use this model as is, and you can simply deploy this model in your model interface, whether it's through your notebook or any other in your Docker container or whatnot, and you can start generating the text. Am I making sense? So that's a Hugging Face model. But my point was, we want you to get to the stage where you understand how to stitch everything together. Right? So there will be so in last week we talked about how to stitch together things with Terraform code, and in coming weeks we will talk about how to utilize those Terraform codes to stitch some of these things together. How to bring your own container, or if you have a container already exist, how are you going to extend that container or your ML code so that you can deploy that container and then run that container as a service. And then we will end up querying that container, and we will apply, let's say we are building something like recognition, for example, right? Then that container will expose that container as a public web service, and we will upload an image, and we will try to recognize whether that image has a dog or a cat, either classification or object detection, or whichever functionality we want to do as a part of that model, right? So that is the end state where we want to have you go through the life cycle of the machine learning. Does that answer your question? I know I was talking a lot
Yes.
about, okay. But it would be a lot of hands-on practical, like what we did last week, or at least some of them did some homework as well on creating a simple Terraform code with just 5 lines, and then deploying that EC2 instance. So it's just a start of using Terraform and EC2. And if you think, Salman, I know you did that last week, right? So the Terraform and EC2 was just this much portion, okay? If you think from this picture point of view, a small block here, the smallest block of this last block. So as a part of this ML in production, probably we are going to do a 30, 40 times bigger than that Terraform code, okay?
Yeah.
All right. So with that, let me stop recording, and then we can talk more. Any other questions you may have. All right. Thank you.